Ook. I'm going to eliminate these because these were from Algebra 1. You guys did all this before. Like, you remember solving equations like variables on both sides and stuff like that? Yeah. Yeah, you've already done that. So this is Algebra 2. And today is 9:13. And I hope everything has gone well to this point so that we can just essentially build upon what we've built. So uh, I don't really know what to call this. It's, let's call it like multi-step factoring. And I don't know why there's that weird box right in the middle. You guys, can you guys see that box? What an odd little fellow. Yeah, okay, so here's what I'm gonna do. I'm just gonna erase the whole, oh my God, it's still there. Okay, I'm just gonna stop. Holy ham on a cracker. I think you're onto something there. What the? Yeah. I think I'm back to normal. Wow. Let's talk about that. Not. So today's the 13th, and I'll write this again, and this time I don't have that creepy little box. So I have some examples that I just kind of custom built / picked, and I tried to think about, you know how Delta goes. Like sometimes I click through it and I try to find every possible example to cover all of the eventualities, and I might have not clicked that 34th time of clicking new problem, and then I go, oh, I missed this. So I'll do my best to sort of cover all of it today. And then the first time you get to a problem where you're like, hey, we didn't talk about this, you know how it goes. Just bring it up when it happens, and then I'll address it with everybody. But this is pretty comprehensive, I think. Maybe I nailed it. I don't know. But I have 1, 2, 3, 4, 5, 6, 7, 9. That might be overkill. These are, I don't know. Let's see how you do. So here's our first one. So what we're trying to accomplish is factoring completely. Like you'll see when I put in the directions, factor each expression completely. From this point forward, I'm going to start bolding and underlining that word because oftentimes that one step is not going to be sufficient. I don't know, I don't remember how many this has, but this will have at least a couple of steps. I think one of the examples in today's notes will have like 4 steps. And so the completely is there to remind us to go all the way. Go until nothing else can go. So what's the first thing you notice about this? Anything? Yeah, Bryce. Okay, I'll take it. Anything else, Kinsley? That's called a common factor. And that observation right there is going to get you partially the way to separating yourself from being a D student for the next 2 weeks to an A student. So first thing we want to look for is there something that's in all of them? Because without that, a lot of the problems we try to do are going to be impossible, like literally impossible. So our first observation is like Kinsley said, hey, this, and this can all be divided by 3. So I'm going to pull out a 3. Do you notice anything else? Mm-hmm. Please continue to think along the lines of what Kinsley said. I'm going to go back to you since you started this. What else? They do. So Kinsley has really gotten the ball rolling for us here. This is for me now, becomes the predominant #1 battle cry. And this will separate your ability to get started on a problem versus your just sitting there being frustrated. Every single problem now that I'm going to give you for the next few days will have a greatest common factor, and you have to pull it out. Because what's happening here is the white problem on the board is not the problem that I really wanted you to factor. It contains what I wanted you to factor, but I essentially spread over the top of it a layer of greatest common factor. So once we pull out the 3 and we pull out the X, what we're going to be left with is the actual math problem that I wanted you to do. So as always is the case, when I pull out a common factor, I'm really just dividing, right? So if I take the first term and I divide him by 3 and divide him by X, what's left? x squared. I took away his 3. I took away one of his x's. Think about the middle term. What's left? Just the 5 is left and just the x is left. And then look at the last term. What's left of him? Just the 24. So what you see now is, oh, so by scraping off that surface, that top layer, I have now dug down and found that's my math problem. And this, of course, is an easy warm-up for us because what have we exposed? What is that? What's that white thing called? It's a quadratic trinomial. This is old school algebra 1 basic skills test. So as I transition now, I've done one step, and now I need to copy down my greatest common factor and complete the process. And the process, as you know, with a rinky-dink quadratic trinomial like this, is build your shells, place your x's, and do your thing. Tell me about my signs. Got to be one of each, and what numbers jump immediately out at you. Because you got to make, yeah, you got to have a 3 and an 8 to make that 5 in the middle. And the balance is we want the heavier number to be the minus so that the balance comes out correctly in favor of the negativity. So we want an 8 minus and a 3 plus. This is our first example, and it is done. So that's what a completed factorization now looks like. The GCF does not go away. It's not something that you're dividing and then throwing in the trash. Like an equation, if you divide both sides by 3, then the 3 goes away. But we're not dividing an equation here. We're keeping track of all the parts and pieces as we dismantle them. Okay, so 1 down, bunch to go. Any questions there? Okay, let's go again, round 2. This one, I'm going to teach you something, and I need you to hear it, ingest it, own it, let it become part of what you just know. What do you notice? Sure, the exponents are pretty big, aren't they? So we have some x's in common, don't we? So that's going to come out in a minute. What else do you notice? There's only 2 terms. So this is going to be interesting. What I think is, okay, maybe when I scrape off the layer of what Mr. Ahern gave me here, maybe when I pull that layer off the top surface, I might expose something unique, like a difference of squares or a sum of cubes or a difference of cubes. Those become the ones that we think about when there's just 2 terms, right? So that's where we're thinking we might be headed, but we can't get there until we correctly pull off the GCF. Now, what I wanted you to really get out of this part of the lesson is this, and you should probably write this down. If it starts with a negative, always pull a negative. And I mean always. So when we find ourselves in step 1, and by the way, from now on, universally, step 1 without question is pull the GCF. That will 100% of the time be the answer to the question, what should we do first? So when I think about pulling the GCF, I need to think about, okay, my notes say when it starts with a negative, pull a negative, right? So as I think about GCFing this down, yes, I know that the 8 and the 18 can both be divided by 2. And yes, I noticed that they both have x's, but more importantly, when I GCF it out, I am pulling a negative. I never want the thing that's left over, like the thing I tried to expose by pulling a GCF, I never want that leftover piece to start with a negative. So I do my due diligence and get the negative out early. Now, what else can I pull? I can pull a 2, and I can pull an x squared. And who knows? What we unearth might be its own factorable expression. It might also just be there. Who knows? So let's see what happens. When we pull the negative 2x squared off the surface of the front, what do we get? 4x squared. It's in the running to be a difference of 2 squares right now, right? But it's got to meet 2 other criteria. First, what's my sign going to be? It's going to go to minus now, isn't it? Because if it started as a plus and I pull a negative, everything switches. So that plus becomes a minus. This is looking good. And what happens to 18x squared if you divide him by 2x squared? What's left? 9. Just 9. And if you said 9x, I really want you to think about why you said that. He doesn't have any more x's. We pulled both of them out. There are none left. Okay. What do you see? This is called a difference of squares. And so my job now is to identify who am I up against. Yeah, getting off the GCF, that you pull that off, that is 100% just an expectation. But once you get it off now, your job is to look and say, who's left? Who am I looking at? That's a difference of squares. So I've got to go another level. I'm going to keep my GCF around. GCFs just hang around like a bad cold. Like you don't get to, no, they're boom, boom, boom. They're always with you every step of the way. And what will that white thing factor down into? What's the square root of 4x squared? So 2x goes here, 2x goes here. What's the square root of 9? So 3 goes here, and 3 goes here. And then to complete, I always use a plus and minus pattern to assassinate that middle term. I just look, and I look again. Can either of those offspring produce more? No. Once you get down to linear factors, then you know you're done. Because quadratics, cubics, quartics, they can sometimes keep going. But this is final. So good there. Next one. So we should have 3 sorts of observations. You got to train and use today to train yourself. GCF, 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 GCF. It's just where we go now. And so when I'm thinking GCF, I should think of the GCF as a 3-headed monster in this case. What's my first observation? Got to pull a negative. Come hell or high water. Like that's at least, I'm doing at least that. What else can I get out of 4, 4, and 48? I can get a 4. And what else can I get? I can get x to the 3rd. Remember, the G in GCF stands for greatest. I want to get as much as I can out of everybody. And now I rebuild. And the rebuilding is where we expose the actual math problem, where we're going to dig in and figure out what we want to see. What's left? 4th. Second term? Minus x to the 2nd. Good job there, Bryce. And last term? Minus 12. What do you see? It's a lookalike. Right? Thank God I know how to do this, right? Thank God we did this before this, because now when I see things, I don't have to reteach the lesson on how to factor a lookalike. Like I know what to do. So I register that this is doable because it's a 4-2-0 pattern of lookalike. And I know that the minus 12 in the back is telling me to think of a 3 and a 4 of some sort. So let's do it. Let's go a step deeper. So we're going to keep our GCF around. And then we're going to build our 2 shells. This is a lookalike trinomial, so we're going to do it the old school way. What's going to go in the beginnings? You bet. Divvy it up, x squared, x squared. Tell me about my signs. 1's plus, 1's minus. And then what numbers am I going to use? Good. And then we look at it and we're like, wow, that was cool. That took, what, 2 steps? But we're not done. And so I wanted to expose you today to this idea that now we're adding a lot of work to the front, maybe not a lot, but we're also potentially adding a lot of work to the end of the problem in that, what do you see still? You see it? This is a what? Difference of squares. They're going to pop up whenever they want to. They can come up in the first step, the second step, the third step. They're going to show up. And when they do, it's your job to look at them and go, I know who you are and I know what to do. So here we go again. Copy down the GCF. You'll hear me refer to this, the thing I'm writing in white, as a dead factor. It's a factor that cannot factor anymore. It's dead. It's like the end of a factor tree. But what does the difference of squares factor down into? Nice job. And at this point, the problem is officially over. The only thing up there that has any potential to be factorable is the x squared plus 3, and that's trash, right? There, you cannot factor a sum of squares anyways. So I'm not using real numbers anyways. You can do it with imaginary. Are we good so far? Okay, let's go again, round 4. I think when I was your age learning math, if I recall, these might have been my least favorite because I'm someone who I tend to overthink things, and I feel like I must be doing something wrong. So hold that thought and come along for this one. What's the first thing we notice? There's a GCF of 5x squared, right? If we accomplish one great thing today, let it be that. You walk out that door today and you're like, GCF, GCF, every time. That's my go-to, GCF, 100%. That's our one goal. So I'm going to pull out a 5, and I'm going to pull out an x squared, and then I'm going to rebuild. And what's left over? 3x to the second plus 4. Let me ask you a question. What's that? It's a dead factor. I wanted to throw at least one of these into today's lecture because this will happen to you where you might sometimes feel like I had to have done something wrong. Like, no, sometimes factoring is pretty unexciting. Sometimes all we can do is pull that GCF layer off the top, only to realize that what's left is it's dead. So this would just be a real simple, like a 10-second problem. Done. Okay. Any questions about that? All right. By the way, there will be no cubes in today's lesson because I clicked through Delta a lot and I could not find any cubes. And so I wanted to stick consistent with what you'll see. Before we do our next assignment, I'll get in the way and I'll show you now next time what it looks like with multi-layer like cube factoring. So today, and I'm not done by the way, but today you'll see quadratic trinomials, difference of squares, I think lookalikes, and what we're about to do, which you'll know right away what it is. Well, you won't know right away, but as soon as I'm done writing it, you'll know what it is. Bless you. What does it just have to be? It's got to be grouping. Good job, Kinsley. You're on a roll today. I know it's grouping because the 4 terms stick out. I'm like, sore thumb, 4 terms, I'm grouping this bad boy. If it's factorable, I'm going to group it. But before I can go down that road, GCF. I can't pull a 9. I must pull a negative. Let that be instinctively step 1. If it starts with a negative, again, if nothing else can come out, at least we got the negative to switch that sign in front. That's job 1. But I can also pull a handful of X's. 3 to be exact. Okay. And now I'm going to rebuild. And what I do when I rebuild is I'm constructing now the actual math problem that someone wants me to do. And so what's left on the front? X to the third minus no, don't give me 3s. Remember, we didn't pull any 9s off of this, guys. So the numbers in front, the coefficients are not changing. So it is still minus 9x squared. Numbers aren't changing because that term in front was pretty uncooperative in that respect. Plus just x. Always be aware of how much you pulled out. And it's not plus 81, it's minus. I want you to look at something. You see this negative that we pulled out? You see it? It's going to change 1, 2, 3, 4. That's the power of negative distribution or undistribution in this case, is it affects everybody. Everybody switches. We good? All right. So these are trickier for me. I've always struggled with the organizational aspect of this. When you look at it on Delta Math, if you look at one of Zach's explanations on there, it can look a little confusing. So I will tell you, in a case like this, this is what I do personally. I take my GCF And I try not to encourage behavior like this, but I move it off to the side. And this is the only time I'm going to tell you that you should do that, because it's very easy to forget about him. But I find that with grouping and how weird grouping looks, when you throw a GCF in front of that, it gets even more intimidating looking. So I take Mr. GCF and I tell him, like, go play on your phone for a few minutes. I'll be back. And now I'm going to do the math problem in parentheses. So here we go. So we're going to draw the wall down the center because it's grouping, and we're going to GCF both sides of the wall. What's the GCF of the left side? It is x squared, leaving behind what? Beautiful. So again, the red thing on the TV should not be in our mind right now. He's on timeout, not a punishing timeout, just to go take a break. It's timeout. And now we're headed to the other side of the wall. And then, of course, the next step is to copy down the sign. So we're going to take the plus, copy it down. What can I pull out of 9x and 81? And then I rebuild. X minus 9. And then I look and I say, huh, jackpot. The white things are the same, so the grouping worked. So now our answer at this point in time is, I now welcome back Mr. GCF. And I say, you can come back now. All right, wrap up what you're doing, come on back. And he now sits in front of my two factors, which are x minus 9 and x squared plus 9. I recollect all the pieces, bring them back in one glorious finale. Is anything that you see on the TV still factorable? You should be really tempted to factor what I just circled in red. But don't. Why? It's a plus. And this will be a conversation, I guarantee you that there will be at least 50 points lost in this room alone over the next 2 weeks on this topic if you don't hear me say this. You cannot factor a sum of squares, not using real numbers. I just watched a couple people write that down. Man, you're smart. You cannot factor a sum of squares. You're going to want to, because it looks so delicious. And where it extra sucks is you can factor a sum of cubes, but you can't do it if they're squares. The sign doesn't cooperate. So even though when I wrote this problem, I placed the x squared plus 9 there for you to try to get us to have this conversation, it cannot be factored. So that's a final answer there. Still going? Sorry, I know this takes a while. Again, I know that for me personally, GCF with grouping was always a struggle. So I thought I'd give you 2 of these in a row. What do you see, first of all? It's grouping for sure, right? We know that's where we're headed. What's the GCF? 4x. And then I rebuild. And here I go. What's left over? Perfect. Keep going. Plus 4x squared. Keep going. Keep going. Done. Good. And again, I'm going to take my GCF and I'm going to tell him to go take a break, get out of my way. It's weird that these problems feel weird to me when the GCF is sticking around like, let me play. Like, no, just go away. So let's draw our little wall and do our thing. So what is the greatest common factor of the two on the left? Yeah. And what's left over? Yeah, it's the best I can do. Next step. Drop the minus. Good job. What can I get out of 5x and 4? 1. And remember that 1 is essential because we need him to give us structure for one of our factors. And then what's left over? Sorry, say again. plus 4. Good. Sign changing is always a struggle. So remember, if we pull a negative, everyone switches. And so then I reconstruct and I welcome Mr. GCF back and I say, hey, come on back. And then I build. Common thing is 5x plus 4. So he gets a single copy. And then the green and the yellow make up the, and are we done? No. So I see this time that I do have something that checks all 3 boxes. To be a difference of squares, you have to be a minus, first of all, and then you have to have a square rootable thing and a square rootable thing. And x squared minus 1 checks all those boxes. So I have yet another step to go. So I have 4x. My 5x plus 4 is a dead factor. What does x squared minus 1 drop down to? Beautiful. Fully factored. And that's great because when we get into our polynomial functions unit, which is what we're preparing for, that's going to tell us that the graph of the original function crosses the x-axis at 0, -4/5, -1, and +1. So where we're headed with this is these factors produce what we call roots or zeros. And they are part of the process of like, how can I then generate a picture of how this 4th degree, 5th degree curve behaves? It goes crosses here, 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 here. And that's really the purpose of factoring, is someday to allow us to find things that we couldn't otherwise find. So we're headed somewhere. You guys feel good? Okay. Let's do a few more. I promise you, you'll have just a lot of work time coming up on the tail end of this, okay? And maybe not all of it today, but tomorrow, of course, for sure. So I got 3 more. Let's finish it off. When I wrote these, I feel like each one had a purpose. It was late last night, and I don't really remember, but let's give it a shot. I think that the purpose of this was, you'll see after we pull the GCF that, well, you'll see. What is the GCF? I'm not going to take any answer you give me unless you put the word negative in front of it, first of all. Okay, so let's get that out of the way first. What is the GCF? Negative something. Good. Let's get that out there. And it is, in fact, -4. What she said. Okay, everyone's got to have it if you're going to pull it out. You see? So let's rebuild. Here we go. What's left? Squared. And listen, you might wonder, like, haven't we already done this? Wasn't this like the first example? But the reason I got a couple of these on the tail end is because I want to make sure that you're aware that you're also going to get trinomials of the poopy variety. And the poopy variety is the one where we've got the multiple templates that we have to deal with, right? So once again, -4, you can just kind of hang around. But what I have to consider is my focus is on breaking down the white thing. So I'm going to bring down my -4. And I'm building 2 shells, 2 sets of shells this time, because I don't know if it's a 5x and a 2x or a 10x and a 1x. But, you know, this ain't our first rodeo. Like, we get the gist. What are my signs going to be? One of each. And again, a good factor doesn't sit here and say, oh gosh, I need help. A good factor says, I can do this. I just got to know that the numbers that make 12 are 1, 12, 2, 6, 3, 4. And I instinctively would start with 3 and 4. I just start where numbers are closer together. So like if I put a 4 here and a 3 here, if it doesn't work, like I can erase, you can erase, right? So let's just try it. What's the worst that can happen? So does it work? Those make 8x. These make -15. We got it. Lucky. First shot. So factoring is still what it was before. Sometimes it's more annoying than others, but none of this matters if we don't get the GCF out, right? So final answer is in the purple box here. And we got it on the first try. So no need for the other template. We didn't need it. And if you tried that template first, then, well, it would take you a little longer. Let's go negative 15 x to the 10th minus 5 x to the 9th plus 50 x to the 8th. GCF. I can pull a negative. I can certainly pull a 5. And I can certainly pull a buttload of x's. So there it is. And then we rebuild, exposing the math problem, which is what? The nothing, because we had 9, we took away 8, x to the 1 is all that's left. And then what's final at the end? Minus 10. So here we go. This is less poopy. Maybe I should have done them in a different order, but this one has the 3 in the front, so it's mildly poopy, but not like the last one where we had all those multiple possibilities. So GCF, come on down. I know there's only one potential template. If this is going to work, it's got to come from 3x and x, and my signs are one of each. And by now, you've probably done enough of these to just instinctively start seeing the numbers that I want you to see. You start thinking about, okay, the number that I'm trying to make in the middle is positive 1, right? The green number. Where could I creatively put some numbers to make two things that have a difference of 1? 5 and 2 are perfect. If you put a 5 and a 2, just like this, it's not perfect, but it's what we want. Close. Because that balance is, look what we did, man, we're pretty smart. We made a 5 and a negative 6. So we're like, flip your space. Factoring starts to feel way less of a clumsy process the more of it you practice. All right, let's do this. Let's make it official. If I wrote this last example, there had to have been a reason. I don't know what it was. I was half listening to Sports Center and it was like 11:22, which is well past when I should be in bed, for the record. So let's do it. Boom. Oh, I remember now. This is why you should always prepare before class, because now I know why I did this. So what is the GCF? Yeah, negative 5x squared. I love how you attack that. It's a 3-step process. Do I get a negative? What number? How many x's? Boom, boom, boom. Good job. What's left over? X to the 4th. Say again? Minus 1. There's a lot of meat on this bone. What an interesting problem. Now I remember. It looks so innocent, but actually we've got 2 layers yet to go. Do you see it by chance? Do you see the layers? You see? It's a look-alike difference of squares, which will then produce 2 offspring, one of which will produce its own offspring. Can you see it coming? All right, let's do this. So let's leave red guy alone. And let's difference of 2 squares factor this white thing down. Let's go. What's the square root of x to the 4th? X squared goes here and here. Square root of 1 is 1, goes here and here. And to make it click and tick, we put a plus and a minus. And then you see it. You're like, hey, that guy on the far right, I know who you are. You can't get past me. You're a difference of squares. There's an imposter next to you. He's a sum of squares. I'll ignore that guy. But you, sir, I can go further. So we have negative 5x squared times dead factor times boom, indeed. That's it. Okay, so let's use the next few minutes because we don't have a lot. We have like 6 to make sure, first of all, that we're all on Delta Math. I think you all got on for my first assignment, but just to be safe. And then the assignment is up there. You'll see it again, the name of it. Don't be confused. I named them more for my sake than yours, but I named this one like A2-6. Algebra 2, assignment number 6. So that's the code. and it should be there. And it's going to be a mixed bag. I don't exactly know. Like they're going to come at you. You'll have a different problem than the kid sitting next to you, different order, all that good stuff. And this is not due tomorrow. We'll work on this tomorrow. But let's see if we knock out like 3 or 4 problems before we get out of here today.